Hello students. In this lecture, I will discuss the important term in the chemistry that is known as resonance. So I will tell you about what is resonance energy, and what are the various rules for writing the resonating structures. So let's start with the what do you mean by resonance? The resonance hybrid means when a molecule cannot be completely represented by a single structure, but its characteristic properties they can be described by two or more different structures. Then the true structure is said to be resonance hybrid of these structures. The possible structures they are called resonating structures, and we say that there is a resonance between the various possible structures. Now, the resonance is also known as the description of the electronic structure of a molecule or a ion by means of several electronic structures in which each structure contributes in the description. Means in the resonating structure only the arrangement of electrons they will differ. So mathematically resonance is expressed as by saying that the wave function describing the molecule, that is psi c, is the linear combination of wave function describing that molecules, means the wave function of the atomic orbitals, that is c1 psi1 plus c2 psi2 plus c3 psi3. In case of hydrogen molecule, see these are the three resonating structures of hydrogen molecule, so it cannot be represented completely either by the single structure. So it is represented by three structures. First one is H, single bond H, that is the structure showing the covalent character of the hydrogen atom. The second and third structure they show the ionic character of the H2 atom. So this hydrogen molecules is considered as a resonance hybrid of the resonating structure involving both covalent and ionic bonding. So resonance is represented by a double-headed arrow. The resonance is always represented by, wait, I will show you this double-headed arrow. So we will represent the resonating structure with this arrow, double-headed arrow. Therefore, the true structure of H2 they can be represented as follows, and the molecule is said to be resonance between the resonating structure. So, due to the resonance, the energy of the molecule becomes lower than any of the resonating structures. Therefore, resonance gives extra stability to the molecule. So, what do you mean by resonance energy? Difference between the actual energy of the molecule and that of the most stable of the resonating structure is known as resonance energy. Higher the resonance energy, greater is the stability of the molecule. Therefore, resonance energy is equal to actual energy of the molecule minus energy of the most stable structure. It should be noted that the various resonating structure of the molecule they have no real physical existence. They are just a convenient way of picturing a molecule in terms of familiar Lewis structures. They have no any physical existence. So the actual structure has no pictorial representation. Now the molecule is said to resonate between the resonating structures. So does no mean the molecule will resonate from one canonical structure to the other. The term resonance has originated from the mathematical analogy between the molecule and the classical phenomena of resonance between the coupled pendulums. Now there are various conditions or rules for writing the resonating structure. The first rule is the position of various atoms in each of the canonical structure must be the same, but the arrangement of electrons may differ. The position of various atoms they must be same, but the arrangement of electron may differ. For example, in case of HOCl or HClO, it cannot be a canonical structure, as HClO has the relative position of HCl and O. They are not the same in the two structure. The position of atom should be same in both the structure, only the arrangement of electron will differ. The second rule is the contributing structure should have the same number of unpaired electrons. The contributing structure they have the same number of unpaired electrons. I mean, for example, if the O2 molecule, in first oxygen molecule they have 6 electrons, means 3 pair of electrons, and in the second oxygen atom they have a 3 pair of electrons, means 6 electrons, total number of electrons 6. Then the second structure also contain the same number of unpaired electrons. So both the structures, they should contain equal number of unpaired electrons. In the contributing structures, like charges should not reside on the adjacent atoms. Otherwise, due to electrostatic repulsion, the structure will appear to be unstable. Clear? So, the like charges should not reside on the, see this in pic, these B positive charge will not reside on the same structure. It should be A minus plus minus. This should be like this, so that it will become stable. So the non-like charges should not reside on adjacent atoms. The fourth one is unlike charges should reside on adjacent atoms in the contributing structures. There should be unlike charges on the adjacent atoms. So this in this structure, A contain positive charge, B contain negative charge, C contain positive charge. So adjacent atoms, they have different charges. Fifth one is in the contributing structure or canonical structure, the negative charge reside on electronegative element and the positive charge reside on the electropositive element. Means the negative charge should be on the electronegative element. If in HF, F is electronegative, then the negative charge reside on the F atom and the positive charge should be on the H atom. It should not be like this, that F become positive and H become negative. So the negative charge should reside on the electronegative atom. So in this, in both the structures, structure 1 is important and it will contribute to the actual structure of HF, but not structure 2, because in structure 2 F contains positive charge whereas F is electronegative. So F should be negative. Sixth rule is the proposed canonical structure should have maximum number of bonds. So these are the various structures that should be contain maximum number of bond, that is more stable. So out of these four structures, structure 2, 3 and 4, which involve a double bond, they contribute more to the actual structure, though a formal positive charge is required by a fluorine atom. The seventh rule is the contributing structure should possess almost identical energy. For example, the three resonating structures of carbonate ion, they almost have similar energy. Hence, they all contribute equal to the actual structure. The contribution of a canonical structure is inversely proportional to its energy. So the structures with higher energy are in general unstable, and the contribution towards resonance will be small or negligible. So these are the various rules before writing the resonating structure of any molecule. So this is very important. So before to write an resonating structure, we have to keep these rules in our mind. So these are the example of some molecules showing resonance. First one is the resonating structure of CO molecule, that is a carbon monoxide. These are the three resonating structures of carbon monoxide. The calculated bond length of double bond and a triple bond between carbon and oxygen, they are 0.122 nanometer and 0.110 nanometer respectively. Therefore, the carbon-oxygen double bond determined by X-ray diffraction is 0.113 nanometer. This value is intermediate between the values of double and a triple bond. Therefore, the carbon monoxide is considered as a resonance hybrid of the above three structure. The experimental value of 0.113 nanometer suggests that the bond between carbon and oxygen is closer to a triple bond. Hence, the structure 2 predominates. Similarly, actual energy of actual bond energy, that is 1057 kilojoules per mole, has been found to be greater than the calculated bond energy of 726 kilojoules per mole. Thus, the resonance energy of carbon monoxide molecule is in between 1057 kilojoules to 727 kilojoules, that is 331 kilojoules per mole. Next is the resonating structure of carbonate ion, that is CO3 2 negative. So these are the two electronics resonating structures of CO3 2 negative ion. The ion is planar and its carbon atom is bonded to two oxygen atom each by single covalent bond, and in the second one oxygen atom by a double covalent bond. This means CO bond should have different bond lengths, but X-ray studies showed that all the CO bonds are of same bond length, that is 0.131 nanometer, which is intermediate between the calculated double bond length, that is 0.12 nanometer, and a single bond length, that is 0.143 nanometer, between carbon and oxygen. Hence, the structure of carbonate ion, they can be represented as a resonance hybrid of the following structure. So, the resonance energy of the carbonate ion is 176 kilojoules per mole. Next is the resonating structure of nitric oxide. So, nitric oxide molecules is considered to have the following two resonating structures. Both these structures show that it has an odd electron molecule. The observed bond length of 0.104 nanometer is intermediate between the calculated double bond length of 0.115 nanometer and a single bond length of 0.10 nanometer between the whole molecule, between the nitrogen and oxygen. So it is assumed that the unpaired electron is spread all over the whole molecule, and hence the molecule is represented with a double bond, that is NO के बीच में, that is the double bond which is present, as well as the 3 electron bond between nitrogen and oxygen as shown in structure 3. So structure 3 suggests a small dipole moment which is confirmed by experimental value of 0.16 T. So this is all about resonance, the resonance energy, and the various rules for writing the resonating structure, and the various example of some of the molecules describing the resonating structure. So if you have any doubt, write your doubt in the comment section. I will answer that questions. So from this topic, the questions, they will become like this: what is resonance, what is resonance energy, and what are the various rules for writing the resonating structures, and what are the various examples. Give the example describing the resonating structures. So you have to explain with the help of some examples. Thank you.